Welcome to G Fun Facts Online, where we unravel the science behind the everyday and the extraordinary. Today, we're looking up at the sky. Picture it, a vibrant blue canvas dotted with dozens of colorful dancing kites. It's a scene of pure joy, a cultural celebration in countries like India, Pakistan, and Brazil, where festivals like Makar Sankranti and Basant fill the air with soaring paper and wood. But what if I told you that hidden within this beautiful spectacle is a lethal weapon? That the string connecting those kites to the ground is not just a tether, but a filament of fatality, engineered with surprising scientific precision to be incredibly sharp and deadly. This isn't just about fun and games. This is the story of how a simple kite string, known as manja, was transformed into a microscopic buzzsaw, leaving a trail of tragedy for humans and wildlife alike. So today, we're going to unravel the material science of these lethal threads, explore the brutal physics of how they cut, and confront the devastating consequences of a tradition that has become dangerously sharp. Let's start by deconstructing the manja, this lethal thread. Its effectiveness comes from a perfect, deadly combination of three things: the thread itself, an abrasive coating, and the adhesive that binds them. It's a triumvirate of destructive design. First, let's talk about the foundation, the thread. In the beginning, this was all very simple. Traditional manja used fine cotton thread. Cotton is cheap, available, and its fibrous nature helps the abrasive coating stick to it. But it's relatively weak. A standard cotton thread might only have a breaking strength of about 2 pounds. To make it stronger, makers would twist multiple strands together. But the 20th century brought a revolution in materials: synthetic polymers. Suddenly, nylon became the thread of choice. Nylon is incredibly strong and durable. Its molecules are lined up in a neat, ordered structure, giving it a much higher tensile strength than the random jumble of molecules in cotton. Then came polyester, often known by its brand name Dacron. Dacron is even better for a kite fighter. It's thinner and lighter than nylon for the same strength, meaning you can pack more line onto your spool. It also has a high melting point, which makes it resistant to the friction and heat generated when two lines rub together at high speed. But these synthetics introduced a new level of danger. Because they're so strong, they are almost impossible to break. If one gets snagged on a tree, a power line, or tragically a person's neck, it doesn't snap. It just stays there, a taut, invisible threat. And unlike cotton, these plastics are not biodegradable. They persist in the environment for hundreds of years. This brings us to the modern apex predator of kite strings, often called Chinese manja. Now, this is a bit of a misnomer as it's often made locally in places like India, but it represents the peak of lethality. These aren't just coated nylon threads. They're often made from synthetic materials that are inherently strong and sharp, sometimes even coated with metal. They are so strong you can't break them by hand, and so thin they're nearly invisible in the air. This is the string that has prompted widespread bans and is responsible for the most horrific accidents. But a strong thread is just the backbone. The real soul of the manja, what turns it from a string into a weapon, is the abrasive coating. This is the layer of microscopic, razor-sharp particles that does the actual cutting. The traditional choice is powdered glass. Makers would literally pound old fluorescent light bulbs or bottles into a fine powder. The effectiveness of glass comes down to its hardness, which we measure on the Mohs scale, from 1 for talc to 10 for diamond. The glass used in bottles has a Mohs hardness of about 6.5. For comparison, a cotton or nylon fiber is significantly softer. On the Mohs scale, a harder material will always scratch a softer one. So when a string coated in hard glass particles is pulled rapidly across a softer string, the glass acts like thousands of tiny cutting tools, gouging and severing the fibers. In fact, at a hardness of 6.5, These glass particles are hard enough to scratch steel, let alone skin and tissue. As if that wasn't enough, some high-performance manja formulations use even more aggressive, industrial-grade abrasives. Materials like aluminum oxide, which has a Mohs hardness of 9, just one step below diamond. Or even zirconia alumina, a ceramic composite that actually self-sharpens as it's used, with tiny pieces fracturing off to reveal new, sharp edges. This stuff is used in industrial grinding wheels. Using it on a kite string is like turning a toy into an industrial cutting filament. And it's not just about what you use, but the shape and size of the particles. You want angular, irregular particles, with sharp edges, not smooth, rounded ones. This is why crushed light bulbs were a traditional favorite. They shatter into incredibly sharp shards, perfect for cutting. The final piece of this deadly puzzle is the adhesive, the glue that holds the abrasive particles onto the string. Without a strong bond, the glass powder would just fly off. Traditionally, this was a simple, glutinous paste made from boiled rice, mixed with tree gums. But today, modern manja often uses powerful synthetic adhesives, creating a tougher, more durable, and more water-resistant bond. The thread is passed through a slurry of this adhesive, the abrasive powder, and a color dye, and then stretched out for hundreds of meters between posts to dry and cure, hardening into a rigid, rasp-like surface. So you have a super strong synthetic thread coated in microscopic, razor-sharp particles of glass or industrial ceramic, all held together by a powerful chemical adhesive. You've successfully engineered a weapon. But how exactly does it work in the sky? The act of one kite string cutting another is a brief, violent event governed by physics. It's not a clean slice like a knife. It's a brutal process of abrasive wear, a microscopic battle. Two things are key: tension and velocity. A kite in the air is already pulling on its string, creating tension. In a kite fight, a skilled flyer will manipulate their line, pulling it in or letting it out rapidly to maximize this tension. When two lines cross, this tension is what holds them together, ensuring firm contact. Then comes velocity. The goal is to create a massive difference in speed between your line and your opponent's, usually by pulling your string in with a fast, sawing motion. The combination of high tension and high speed generates incredible friction and maximizes the energy delivered by those tiny abrasive particles. What's happening on a microscopic level is a process called abrasive wear. The sharp glass particles on the attacking string are dragged across the softer surface of the opponent's thread. Each particle acts like the tooth of a file, digging in and carving out a tiny sliver of material. This is called micro-cutting. With thousands of particles, each pass of the string creates thousands of tiny grooves, rapidly weakening the opponent's line. The stress causes the individual fibers in the thread to fatigue and break until the entire string reaches a catastrophic failure point and snaps. The winner shouts, "Kai poche," which means, "I have cut." The string with the harder abrasive, the sharper particles, and the higher tensile strength will almost always win. It's a high-speed grinding process, and it's brutally effective. The terrifying part is that the physics doesn't care what it's cutting. The same principles that allow one kite string to sever another apply when that same string comes into contact with the neck of a motorcyclist or the wing of a bird. The object's own movement provides the velocity, the string's tension provides the pressure, and the abrasive particles do their devastating work. A sport is instantly transformed into a deadly weapon. This brings us to the grim consequences. The same properties that make manja a marvel of destructive efficiency in the air make it an indiscriminate killer on the ground. Severed or abandoned strings get snagged on trees and poles, hanging like invisible traps over public streets. The most frequent and horrified victims are people on motorcycles and bicycles. A rider traveling at even a moderate speed can have their throat slit by a taut manja line before they even know what's happened. There are numerous documented fatalities every year across India and Pakistan from these incidents. Pedestrians can walk into unseen threads, suffering deep cuts to their face and hands. Even the kite flyers themselves often have scarred fingers from handling the string. Then there's the impact on wildlife, which is staggering. For birds, the sky becomes a deadly maze of invisible wires. They fly into the strings and become entangled. As they struggle, the abrasive manja slices through their feathers, skin, and even bone. Wildlife rescue centers are inundated during kite festivals. One charity in Ahmedabad reported treating 4,000 birds during the 2024 festival season. They see birds with wings completely amputated, left to die a slow, agonizing death from blood loss or starvation, hanging from a non-biodegradable nylon thread. And that's the other part of the problem, the environmental damage. The old cotton strings would eventually biodegrade, but modern synthetic manja is plastic pollution. It persists in the environment for hundreds of years, clogging drains and posing a threat to any animal that might get entangled in it or ingest it. Birds even unknowingly weave these deadly threads into their nests, creating a death trap for their own chicks. In response to this trail of devastation, governments have been forced to act. In 2017, India's National Green Tribunal imposed a nationwide ban on any manja made from nylon, plastic, or any other synthetic, non-biodegradable material. Many states have gone even further, banning all sharp manja, including the traditional glass-coated cotton strings, permitting only plain, uncoated cotton thread. But enforcement is a huge challenge. The sale of banned manja simply goes underground. Despite police raids seizing thousands of spools, the demand from competitive flyers remains high, and sellers find ways to meet it. The tragic headlines repeat every year. So what's the future? How can we preserve the joy of this tradition without the deadly cost? The solution isn't to stop flying kites. It's to evolve the tradition. The primary alternative is simple. Go back to basics. Fly kites with plain, uncoated cotton thread. It's safe for people and animals, it's biodegradable, and for the vast majority of people who just want to enjoy seeing a kite in the sky, it's perfectly adequate. For the competitive kite fighters, the sport can be reimagined. Instead of aiming to cut the opponent's line, competitions can use line touch rules, where victory comes from skillfully wrapping your line around another to force their kite down. It becomes a test of maneuvering skill, not the destructive power of your equipment. Ultimately, this requires a shift in mindset, driven by awareness and education. We need to share the stories of the victims, both human and animal, to drive home the real-world consequences of using these dangerous strings. The future of kite flying hinges on the community's willingness to adapt. The sight of a sky full of kites should be a symbol of pure joy, not a source of fear. By embracing safer materials and a more compassionate approach, we can ensure the skies are safe for everyone. And the cry of Kai Po Che can once again be a shout of pure sporting triumph, not a harbinger of tragedy. Thanks for tuning in to G Fun Facts Online.